Well, hello everybody, welcome. Today I sort of want to do a project with you, a little bit of a different format, and I think you'll actually have fun. But rather than just have you watch me do the project, I'd like you to join with me and do it yourself as well. Because if you can do the project yourself, and if you can make the discovery that I'm going to show you with your own mind, it'll actually be much better for you than if you just watch me do it. So take a few moments here and get yourself some materials together. What you would need is the following. Let's see here. You would need 2 sheets of graph paper, 3 colored pencils or markers, some scissors, some tape, and a calculator. So go ahead and press pause on the video and take a few moments and pull those things together, because I don't want to rob you of the joy of discovering this for yourself. So I'm going to leave it to you to do it if you can do it with me. So press pause. I will be right back. All right, moving my stuff out of the way, but all within easy reach. Okay, so start with your graph paper here. I've got a piece of, it's probably 1/4 inch grid, but you can be whatever you like. Just make sure it's not too big or too small, because some things need to fit here. This is probably a good size for what we're going to do. And over in the lower left-hand corner, I'm going to make a mark somewhere over in here. I got to give myself a little bit of a margin. I'll make a mark right here. Okay, now I'm going to count 5 units over and make another mark. 1, 2, 3, 4, 5. And make another mark. So the distance from the left point to the right point should be 5 grids. All right, now I'm going to count over 12. So 1, 2, 3. Oh wait, there's a song for that. Do you know the song? 1, 2, 3, 4, 5, 6, 7. Whoops, hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's try that one more time. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. Good. All right, so now go up 12 units from this marker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And come over 12, and so basically what we're going to be doing is we're going to be making a 12 by 12 square here. Let's double check and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're in. All right, so carefully, especially on the corners need to be precise. Corners, I'm going to make myself a little square right here. (12 by 12). You do the same thing on your sheet of graph paper. So this is going to be 12 here, and this is going to be 12 here. And take a moment and color it in. Pick one of the colors that you've got for your markers or whatnot, and color it in. I'm going to press pause and color mine in. You press pause and you do the same. Okay, I've colored mine in. Color it in lightly, because I still want to be able to see the grid marks underneath here. Now, if it's a 12 by 12 square, how many individual little grid squares do I have inside here? You should see very clearly that that's 12 squared, which 12 to the 2nd exponent, which is why that exponent is called square, because it gives you the area of a square. That would be 144. Isn't that so gross? Yes, it is, because a gross is a dozen, and so that's exactly gross, which is 144. So anyway, there we go. It's 144. Now, go up to the upper left-hand corner right here and count to the left 5 units. 1, 2, 3, 4, 5. Actually, it should line up with the mark down here. The only reason for this mark right there was to give us room to go to the left 5 units. So make yourself a mark 5 units left, and then from the same corner 5 units up. 1, 2, 3, 4, 5 units up. And then make a 5 by 5 square here. Be very careful on the corners. The corners can't be sloppy. Corners have to be precise. And then press pause on the video and lightly color that in. And I will do the same here in just a moment. Okay, now mine's colored in. This is a 5 by 5 square. So what is the area here in this blue square? or the number of grid marks, you should see that that's 25. Okay, good? All right, set this piece of paper aside. Get yourself the second sheet of paper, and I want you to mark out a 13 by 13 square. So I'm going to pick just anywhere in the middle. It's just got to fit. Be mindful of holes. You don't want any holes in the area. So I'm going to come over here, and I'm going to make a 13 by 13 square, and do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So then you're going to mark this off. You're going to then color that in, write the number of the area of square units in the middle, and then use your scissors and cut that guy out, right? Okay, press pause. I'll be right back. All right, I'm checking in. How you doing? Here's my square. I'm coloring it in red, 13 by 13, which makes the number of grids in the middle, or the area, 169. Okay, now, again, this one needs to be cut out. So, be very, very careful, but on the corners, cut it out exactly on the lines. Okay, go for it. Press pause, get that guy cut out. Okay, here we go. A 169 square. Go get your other sheet of paper. Now these two go together. There is a very wonderful and special way that these squares go together. And so what I want you to do is I want you to, here, let me zoom out just a little bit. What I want you to do is I want you to find the way that these squares go together. And so take this square and do what you think you need to do with it, and press pause in the video, put it where you think it might go, and then press play again, and we'll see if you get it right. If you put it here, which is what most people do, no, that's not right. Where else could it go? Oh, it can go right here. Yeah, that's how they go together. No. They go like this. No. How do they go? I'll tell you what. Everything has to line up precisely. There is an exact way to put these together. It's not this, because I got like this extra part over here and this extra little one spot over here. There's something that you can do with these three squares so that this corner and this corner would line up, or this one or the top one. Somehow the corners all line up on top together. And it's not something like, you know, this where one's on top of the other one. It's not overlaid. There's no overlap. Where do you need to put these things so that they exactly line up corner to corner? Getting closer. Getting closer. In fact, if I take the corner right here and put it on this open corner right here, and take that corner of the red one right there and put it on that open corner right there, they will line up exactly corner to corner to corner. And now I'm going to use my tape, and I'm going to exactly mark this down. If you're a little sloppy with either drawing it or cutting it out or whatnot, it won't work. But if you did it precisely, they should fit. And get this one over here. And there we go. That, my friends, is the Pythagorean theorem. Woohoo! You say, what? Like, I thought the Pythagorean theorem was based upon a triangle. No, squares. Actually, what it is this. the area of the big square right here is exactly equal to the sum of the areas of these two squares, but only if you join them right there with a at a right angle. So here's the Pythagorean theorem. The Pythagorean theorem says that the area of the big one is equal to the area of the first one plus the area of the second one when you add them together. And I bet you $1 that if you add together 144 and 25, you would get 169. Okay? That's the Pythagorean theorem. The Pythagorean theorem is based upon areas of squares. If you take two squares and you join them at a right angle with on their corners here, then the square that you would get by connecting the open corners, this open corner with that open corner, the area of that square is exactly equal to the sum of the other two areas. Nifty, huh? But most of you are used to the Pythagorean theorem being a triangle. And if you look carefully, you can actually see a triangle. The triangle is right here. The triangle is the hole in the middle of the area of the squares. Now, I want to point something else out to you now. By the way, let me just run the numbers here. This was, area here was 169. That had to equal 25 plus 144. 169, that was 13 squared. And that has to be equal to 5 squared plus 12 squared. And so now, as you can see, if I call this side right here C, and I call the short little side then A, and I call the longer side but not the longest side B, then I get C squared is equal to A squared plus B squared. Nice, there's your Pythagorean theorem. Now, it's not just a number puzzle. It controls real space. As I showed you right here, like the squares go together, physical squares. It's not just some kind of abstract numbers that when I add them up, I get something that's the same thing. Like it's got real physical space associated with it. Let me show you another example. So let me do, I've got a sheet of centimeter grid paper right here. And if I use my centimeter ruler here, let me kind of come in a little closer. If I use my centimeter ruler here to double check, if I just put it on the end here and go from 1 to 1, can you see that this is grid lines a centimeter? So let's do something a little bit different. Let's do, let's say, start right here, and let's do 1, 2, 3, 4. 4 this way. So that's 4. And then let me go up. 1, 2, 3. And let me make a triangle, a right triangle, out of these. Right there. And then that's 4. That's 3. My question is, how long is that side right there? Well, if we use the Pythagorean theorem, which as you know, says that this side length, the unknown, is equal to this side length here, 3 squared plus 4 squared. That's going to be 9 plus 16. That's equal to 25, and then it has to be the square root of this. This should be 5 units long. Is it? Let me be very, very precise. Put that right up there. Swing it over. It should be lining up. Look at that. 5 units long. It'll be the same for everything. How about this one? How about a 5 by 6? 1, 2, 3, 4, 5 here. And then up. 1, 2, 3, 4, 5, 6. And then I'll connect these. How long is that? If you want to do the Pythagorean theorem on this triangle right here, this is 5, this is 6. You wind up with, what, the square root of 61 should be about 7.8 according to my mathematics. Let me come up here now and let me do this with the ruler, 7.8. Look, here's 7.8 right there. Is it on? It sure looks on to me. Why does this happen? Why does mathematics control physical space? Or let me say it a different way. Why does the physical world obey mathematics? That's wonderful. What's going on? You guys should read some Galileo or some Pascal or even some of the ancient mathematician Ptolemy. We discuss why that is. But it's wonderful. And it's wonderful, I think, that human beings can discover and use this connection between mathematics and the physical world. All right, now it's time to get serious with some problem solving stuff. That was fun. Let's now go over to some notes and some problem solving. Okay, so the Pythagorean theorem, as we've seen, is what you get when you join